Denaturation is the first process of coagulation. Coagulation is the change of a liquid into a soft, semi-solid clot or solid mass. A classic example of denaturation of heat causing coagulation is a cooked egg. When an egg exposed to high heat, the egg changes from a liquid form to a solid. Hydrogen bonds are broken, thus changing the egg's color, viscosity, and texture. This type of denaturation is irreversible. As stated before, pH can also denature proteins. A change in pH would cause a change in ions, therefore disrupting the hydrogen bonding and the ionic bonding. Extremes in pH can alter the protein's charge, which causes unfolding of the protein structure. Salts can also be a denaturant for proteins. When in high concentrations, salt can disrupt the salt bridges within the protein. With an increase in salt concentration, it lowers the solubility of the protein, precipitation, which is salting out, and thus it increases. An example of denaturation of salt by salt is with milk proteins. The salts will dehydrate the milk protein and cause a precipitation and curdling. This type of denaturation is irreversible. Agitation can also cause a protein to denature. Agitation stretch polypeptide chains and disrupt all types of interactions within the protein. Whipping or beating an egg white is an example of denaturation by agitation. Egg white proteins are stretched to stabilize the liquid layer around the air bubble. The stretching and change in the basic native egg protein leads to a denatured, stable form, a gas and liquid, colloidal dispersion. This type of denaturation is irreversible as well. An example of protein denaturation that is reversible is when vitamin C is added to a cooked egg white. When vitamin C is added to a cooked egg white, it turns back to its uncooked form.